Right, so this is part 2 of electrostatics, and we're focusing now a little bit on Coulomb's law. Coulomb's law, the general formula, as we already know, is the same. It is going to be F equals K Q1 Q2 over R squared. A couple of things you need to just keep in mind. The K is a constant. It is given to you, and we will use 9 times 10 to the positive 9 for that one. That will be my K. And we use the magnitude only. This is a vector, so the addition is done by adding the vectors. So we use a magnitude only. If I have a positive or a negative, I only write the number. A third thing that will be helpful for any of the questions is basically knowing what happens to the force if I change the charge. If you can see that I'm having the charges at top, these are up here, they're multiplying. These are directly proportional with the force. Bigger charge, bigger force. Look at the distance though. I'm dividing by the distance. That means it's inversely proportional, which means if I increase the distance, my force will decrease quite a lot. It will actually decrease by square or by a factor of 4. So keep that in mind for questions, and then we'll discuss the directions as well. So in this case, you place them at a distance r, then you double each charge and double the distance. I have shown you how to solve this in an easy way. Just set everything to 1 and then change only the things you need to change. I know K is supposed to be 9. I'm not going to do that. I'm not going to do that. I'm just going to write 1 multiplied by 1 times 1 divided by R1 squared. Look what happens. That is just 1. Now I'm going to change the things it said. I doubled each charge. So I'm not going to do that anymore. Let me try it again over here now. I'll keep my K as 1. I know it's supposed to be this number. I'm going to keep it at 1. I'm doubling each charge. So Q doubled and the other Q also doubled. And I have, what have I done? I have doubled the distance as well. That is 2 squared. Now, let's see what happens. 2 times 2 is 4. 4 divided by 2 squared. 2 squared is also 4. And that leaves me with 1 again. In this case, the force is the same. I did not change it. It did not increase. It did not decrease. So the new force will be exactly the same. So here is another example. In this case, all we're changing now is we're just changing the distance. We're doubling the distance. Not doubling, yes, doubling. So 1 times 1 times 1 divided by, I'm just going to go ahead and double my distance now, 2 squared. What will that give me? So K, Q1, Q2, keep them as 1, 2 squared, 1 over 4, F. 1 over 4, it reduced to a quarter. 1 over 4 is the same as F over 4. That is the same answer. The force between these two charges is this. Find the distance, the separation. So we can just directly use our formula, and you can go ahead and use shift solve, or we can rearrange. F equals K Q1 Q2 over R squared. If I do that, I substitute the numbers in, and what I can do is shift solve or rearrange the formula. It's good to know. I will just swap these two around. I'll have my R equals K Q1 Q2 over F, and because it was squared, I will take the square root of everything. Sorry for the bad handwriting. I am using a terrible mouse. I'll need to get a new one. So I'm just going to write 9 times 10 to the 9 multiplied by 25 micro. 25 times 10 to the minus 6 times 10 to the minus 6. Micro is minus 6 multiplied by 10, not minus 10, 10 times 10 to the minus 6. It's going to take forever to write it out. Divided by 8. Taking the square root, I have already solved this. You should get 0.53. So you can check that yourself. Over here, we're talking about vector addition now. This is great. So we're just going to draw some arrows and see what will happen. 3 charges, straight line. What is the direction on the middle charge? So this is a minus, this is a plus, and this is a plus as well. So we can see that I'm focusing on him. They all will have a force, but I'm focusing on him. He is attracted by this one, F1. He is also repelled by this one. So, in fact, he will have both forces pointing to the left. His overall, adding the two arrows together, will be a big force going to the left. So, in this case, of course, the answer must be B. If the question asked you for another one, you just apply the same idea. and then you can solve it from that. For example, here we go, there's another one. So now it's just the same idea. This is minus, and then again a plus, and then again another plus, okay? So looking at this one here, we have realized that, yes, he is here, and he will be maybe repelled by him, but attracted by him. And you might think, okay, look at that, I have doubled a charge. But the problem is, that doesn't mean it's going to be stronger. No. Not only have I doubled the charge, I have also doubled that distance. This distance is twice as long as this distance. Now, if you remember, it's distance squared. It's distance squared. So that means this is going to be worth more, stronger. The closer the charge, much, much stronger. Apologies for the noise, this girl's leaving the exam. So that means, back onto this, you will realize that this force is a stronger force than this force. The right force will be stronger than the left force. So they will cancel, but not as much. Overall, it will be going to the right. All right, nice. So, moving on to the next one, we have 3 charges arranged at the corner of a square. So for this one over here, we were asking about the lower right charge. So first of all, he is going to be attracted by this person, and he will be repelled by this one, because this is going to be plus. Up and right. You can make a little triangle using vector addition. It will go like this, perhaps. It will go up like this, and you will have that. Or you can do it the other way. I can go up first, then I can go to the right, and I can go along like this over here. So that means either way, my resultant is going kind of northeast. It's kind of going like that in between the two. So that's the answer there for you. C would be the answer. The next one over here, we're going to move on to question 40, which is same idea, but now we have this minus q. He is attracted, and repelled a little. These two distances are closer than this one. This is the hypotenuse of a little triangle. This is a longer distance than these two. Remember what I said up here? The distance squared, it makes a much bigger deal. The distance squared, which means, yes, it will go up, it will go left, and it will come back down a little, but the result will still be start to finish up in that way. This repelling force is weaker than these two forces. And you can always double check by doing the vector addition simulation. We did that in class. You can also check that out again. The link is in the PowerPoint, or you can just search it on Google. The final question on this page, we've got this one here. We're looking for what happens at negative q. Where is he going to go? Which direction? Let's find out. So he is attracted, but repelled. Exactly the same idea as here. These two distances are closer, which means the forces here and here will be stronger. There is a repelling force, but overall he will still come down towards C. The reasoning is the same as the other one over there. Okay, moving on to the next page, we've got a couple more here. Looking at this question, we have a plus, and a minus, and the top charge, you're asked to find where it's going to go. It's asking for that one. So let's do it. He will be repelled, he will be attracted, so it's going to go like that, right? It's going to go like that. You can do the vector addition again, and you can do that, and it will go to the right, like this. So that means you're going to have C, horizontally to the right. Which of the following produces the largest net force on the charge? So in this case, you're going to see that the closer the distance, the stronger the charge. And the further the distance, the weaker the charge. So if I have this and minus 1 and 1, you can use the quick little trip that I just said. 1 times 1 times 2. I'm going to divide that by 1, and that will just give me a total of 2f. I can do the same thing over here. 1 times 1 times 1 divided by 0.5. 0.5 squared, that will give me 4f. Already that's pretty strong. For these two, you will do the same thing, but I need to do it 2 times, and I have to cancel them out. You can take your time to figure that out. You'll realize that this one will only work out to be a half f once you do it, and these two will completely cancel, which will just be f. The best answer is going to be B. So I'm moving on to the next one over here. We're trying to figure out what happens, find the magnitude of the net force on this charge at the origin if there is this charge and this charge. So it's basically like a little graph. So if I'm going to have a little graph, I'm going to have my origin here, and this charge at the origin is 1.2 microcoulombs. From this, so this is my x and y, and this is my x and y. The first charge, which is 2.40, at 3x and 0y. So that is basically along the x direction, maybe here. This is 3 meters away. This is 3 meters away. So that is going to be 2.40. The next one says 0, 4. So x is 0, y is 4. So that means I'll be up to here somewhere. This will be 4, like that. And this is going to be 5.7. It's technically minus, but I'm only going to use the absolute values for this one. And we need to basically calculate what happens. You know what? I will include the minus. That's a minus, that's a plus, and this one was also a plus. Once we've done that, it's actually quite a few steps that you do need to do. 3 steps, I would say. Superposition. You calculate the first force, any one you want. I can do F1 equals K Q1 Q2 over R squared. That will be these numbers here. And then I will find F2. F2 equals K Q1 Q3 over R squared. Now that is these two. The numbers are here. You can try it yourself. Once you've solved them, you can now find the result. It is going to be in a triangular shape, so of course he will repel a little bit to the left. He will be repelled this way because of this plus and a plus. He is attracted that way. If you remember, it just goes in that direction, and this just looks like a little triangle. You solve the two numbers, so it doesn't matter which one's which. You can just directly use Pythagoras' theorem. C squared equals A squared plus B squared. You will do that to get your answer. If I want C, I will just do the square root of A squared plus B squared, and directly you'll get it. A and B are these two forces. I will call that A, and I can call that one B. And then, if you solve it, you will get, hopefully, the answer of 4,800. It will be 4.8 kilonewtons. So you can give that a try yourself. And over here, now looking at this one, this is being attracted. So by this one and by this one. What does it say? Well, of course, if it's attracted to both of these, this must be opposite to both of these. Maybe minus, maybe plus, maybe plus. That would be the answer here. All right. And the next question over here is saying talk about the magnitude of them. So remember, look at the size of the arrow. This and then this. I have doubled this distance. If you remember, doubling the distance would make the arrow a quarter. The first force, if it's here, if these two values were the same size, 1 times 1 times 1 divided by 2 squared, it should have been 1/4. The arrow should be about maybe here, a quarter. But that's not the case. Look at that. This arrow, 1 and 3, is more like 3/4. It's been pushed to 3/4. The only way I can do that is if I increased one of the charges. That way, this can become maybe 3/4. Maybe I tripled the charge, perhaps. And that means I know Q1 is stronger than Q2. Q1 is greater than Q2, which must be the magnitude of Q1 is greater than the magnitude of Q2. So moving on, this is getting a bit lengthy, so I'll make this the last question over here. In this case, we have an object which has got a charge, and the other one has a bigger charge. Now, this is a bit of a trick question. It is actually Newton's third law. Newton's third law is every action has an equal and opposite reaction. Every force has an equal but opposite force. So F1 will be equal and opposite to F2. It's written like this in the formula way. So that means you know that if they are going to be attracting, first of all, the force is the same. Doesn't matter about the charge. If I calculate the force, I'll be doing Q1 multiplied by Q2. It's the same thing as doing Q2 multiplied by Q1. 1 times 2 is the same as 2 times 1. In this case, they will be towards each other. So opposite directions. So I'm going to leave that one there. I'm going to continue in another video.